As we contemplate the sun, we are aware of its enormous power and the energy it emanates throughout our solar system. It is difficult to imagine anything being able to surpass our sun. Yet beyond our own star lies a cosmic wonder that makes even the mightiest solar giants seem insignificant in comparison. Betelgeuse, the red supergiant, defies explanation with its irregular pulsations, huge diameter, and unpredictable behavior. The star is an enigma to scientists, who are still studying its power and potential. As they investigate this magnificent star in depth, they have discovered something terrifying. Come on this tour with us as we delve into the constellation Orion with the James Webb Telescope and explore how its arrival could change our understanding of the route and its impact on the cosmos. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be certain to enjoy this video and activate the notifications. Though many people are unaware of this fact, it is possible to, during the night, look for Betelgeuse in the sky during the winter months in the northern hemisphere. Just look up at the sky and focus on the constellations Orion and Canis Major to see this dazzling star in all its splendor. You can easily locate the reddish-orange star that marks the upper left corner of the rectangular shape of the constellation. The star is one of the largest and brightest in the night sky, making it difficult to miss. However, if you have looked closely at the star, you will be aware of the fact that it does not remain constant. In fact, it varies in brightness periodically. This peculiarity is no coincidence, since Betelgeuse, as the star is called, is no ordinary star. Although to us it may appear to be just one more in the vast firmament, it is located at a distance of more than 640 light-years from us. At first glance, this figure may not seem impressive, but in reality, it represents an enormous distance. To illustrate this magnitude, let's say we were able to travel at the speed of light, which unfortunately is not possible. Even in that hypothetical scenario, it would take us more than 640 years to reach Betelgeuse. If we wanted to undertake such a journey in a spacecraft, even using our most advanced technologies, it would take us more than 12 million years to reach it. This figure far exceeds the entire history of human civilization on Earth. However, Betelgeuse's lack of light is not due only to the distance that separates us from it. Betelgeuse is what is known as a pulsating red supergiant, which means that it is an ancient, massive star that undergoes expansions and contractions. During these cycles, its brightness can vary in the night sky, becoming more intense or dimmer. These brightness changes can occur over extended periods, ranging from tens to hundreds of days. The amazing thing is that Betelgeuse can oscillate in brightness over a wide range. It can go all the way up to a magnitude of 0.5 to reach 0 magnitude, making it extremely bright. These changes follow cycles, with the shortest being 185 days and the longest being 235 days. At times, Betelgeuse can become quite faint, which is called its minimum magnitude. In February 2021, it was reported to present its lowest minimum magnitude in a long time, reaching a magnitude of plus 1.614. Despite its relative brightness, it is definitely fainter than how we usually observe Betelgeuse. However, brightness is not the only outstanding feature of the star. Betelgeuse is known for its distinctive reddish color, which is due to its cool surface, which has a temperature of about 3,500 Kelvin. This temperature is much lower than the surface of our Sun, which reaches 5,500 Kelvin. This lower temperature means that Betelgeuse emits much less energy per unit area compared to the Sun. Consequently, despite being one of the largest stars we know, it appears much dimmer. Betelgeuse is like a giant that is satisfied with a low profile and doesn't need to show off its size to feel important. However, don't be deceived by its appearance. Betelgeuse is a supergiant star that is about 20 times the mass of our Sun. This is one of the reasons why this star has been the subject of numerous studies over the centuries. It has been a prominent object in the night sky and was first identified by the ancient Greek astronomer Ptolemy. Its name in Arabic means the armpit of Orion. Though not much could be known about Betelgeuse at the time, modern telescopes have enabled researchers to study this phenomenon in greater detail. By analyzing the light emitted by Betelgeuse, astronomers have been able to determine many of its properties, such as its size, temperature, and composition. The Hubble Space Telescope, for instance, has provided comprehensive images of Betelgeuse's surface, revealing intricate patterns of gas and dust. These observations have allowed researchers to create models to understand the star's behavior and predict its future evolution. Betelgeuse has also been studied using the Atacama Large Millimeter-Submillimeter Array, or ALMA, a state-of-the-art observatory located in Chile. ALMA has provided high-resolution images of the surface of Betelgeuse, revealing details about its structure and behavior. One of the most remarkable discoveries made by ALMA is the presence of an extensive plume of gas extending from the surface of the star. This plume is believed to be caused by pulsations from Betelgeuse. These pulsations can be explained by a process called convection, involving the rising of hot gas and the sinking of cold gas. This motion creates waves that travel through the star's atmosphere, causing it to expand and contract. Thanks to the Hubble Space Telescope, detailed images of Betelgeuse's surface have also been obtained, revealing intricate patterns of gas and dust. These observations have allowed scientists to create models to understand the star's behavior and determine how it might act in the future. Additionally, the surface of Veru is marked by dark spots, also known as star spots or magnetic spots. These areas on the star's surface exhibit particularly strong magnetic intensity. These regions, known as star spots, are areas on the surface of VTO Rouge that are cooler. This is because the star's magnetic field inhibits the flow of gas from the interior to the surface, creating a cooling effect. Because of this, the spots appear darker compared to the rest of the surface. VTO Rouge's magnetic field is thought to be thousands of times stronger than that of the Sun. This intense magnetic field causes the gas on the surface of the star to be trapped in loops or arcs, describing regions of intense magnetic activity that are visible as star spots. It is important to mention that the presence of star spots is not unique to VTO Rouge. They are also observed in other stars, including our own Sun. The star spots on VTO Rouge are especially interesting because of their size, a number of times larger than Earth, and cover up to 20% of the star's surface, which is significantly larger and more numerous than the sunspots on the Sun. These star spots may have an impact on the overall brightness of the star and cause variations as the spots move in and out of view. VTO Rouge's brightness can fluctuate. This is because the spots, being cooler, emit less light than the surrounding gas, which contributes to changes in the observed brightness of the star. In the case of VTO Rouge, pulsations of the star also contribute to the brightness variations. As the star expands and contracts, star spots move in and out of view, further amplifying the star's observed brightness. Surprisingly, VTO Rouge is not as original as one might think. While there are not many stars like it, there are some that share certain similarities and are equally fascinating. One of VTO Rouge's cosmic cousins is a red supergiant, Antares, located in the constellation Scorpius. Antares is also a variable star, meaning that it undergoes changes in brightness over time, just like VTO Rouge. In addition, Antares has a mass approximately 12 times that of the Sun, with a radius 700 times that of the Sun. So it's safe to say that Antares is no slouch in terms of size. Now, what do you think? Do you think it's just a matter of time before we see VTO Rouge explode in our skies? Let us know in the comments box. If you like the video, like and subscribe to the channel. Thank you so much for watching. See you soon. One of the most pressing questions about VTO Rouge is whether it's approaching the final stage of its stellar career. Red supergiants like VTO Rouge are close to the end of their lifespans, and it's widely believed that such stars explode violently as a supernova. This cataclysmic event releases an unimaginable amount of energy, briefly outshining entire galaxies. Scientists suspect that VTO Rouge might be nearing this sudden outcome. The unusual dimming events in recent years, particularly the Great Dimming, of late 2019 and early 2020, caught the attention of astronomers worldwide. For a time, VTO Rouge became significantly dimmer, sparking speculation that a supernova might be imminent. However, further studies revealed that this dimming was not caused by a supernova precursor, but rather by a huge cloud of dust that was released from the star itself. This finding, while not as dramatic, was still groundbreaking, as it helped refine our understanding of how massive stars lose mass in the years leading up to their death. So, let's say it did explode. What would that look like from Earth? First of all, there's no need to worry. VTO Rouge is far enough away, at about 640 to 700 light-years, that its explosion would not pose any threat to Earth. Even at its brightest, the blast would be harmless to life but incredibly visible to the naked eye. If it exploded, scientists believe it would become so bright that it would be visible in the daytime sky for weeks, possibly even months. At night, it would outshine the full moon. The after effects of the supernova, called a supernova remnant, would linger in our skies for years, possibly centuries. For astronomers, a nearby supernova like this would be a once-in-a-lifetime event, offering real-time data on stellar explosions, black hole or neutron star formation, and the creation of heavy elements in the universe. After a red supergiant, like VTO Rouge, explodes, what remains depends on the mass of its core. If the core is below a certain threshold, it collapses into a neutron star, a dense object about the size of a city but with more mass than the sun. If it's more massive, it may form a black hole, warping space-time around it and swallowing anything nearby. For VTO Rouge, either outcome is possible. Its mass is near the tipping point, so scientists aren't sure which path it will take. That's why continued observation is so important. Multiple observatories around the world and in space are constantly monitoring VTO Rouge. The Hubble Space Telescope captures high-resolution images of its surface and the dust swirling around it. The ALMA array in Chile peeks into gas layers ejected from the star, while the James Webb Space Telescope offers unprecedented detail in the infrared spectrum, allowing astronomers to see through those dense dust clouds. Ground-based telescopes, like the Very Large Telescope, VLT, and others, also track its brightness, motion, and spectral changes regularly. All of this data combined gives us a clearer picture of the star's behavior and possible future. While other red supergiants, such as Antares or Mu Cephei, are also enormous and intriguing, VTO Rouge holds a unique place in the sky. It's one of the closest and largest stars of its kind, making it a perfect laboratory for studying the physics of massive stellar evolution. It's not only massive but also extremely unstable, with unusual variability, dust activity, and surface changes. The sheer size is mind-boggling. If placed at the center of our solar system, it would engulf everything out to Jupiter's orbit. Yet, despite its grandeur, it remains a faint, flickering ember in our night sky, mysterious and powerful, but still cloaked in cosmic mystery.